the few instructions which we saw in the previous examples. Move, MOV. What are the instructions? Move, jump, add. So we saw some few instructions. We'll see the other, generally what are the types of instructions available. Data transfer instruction, arithmetic instruction, logical instructions, string manipulation, process, control, and then control transfer instructions. So the instructions which involve data, okay, like A, B, or accumulator, address, base address, or straight away the address itself. So those are all coming under what instructions? Data transfer instructions. Okay. So instructions which involve the data, they are all instructions, instructions. Okay. There are two operands involved, source and destination. Basically, one condition is there, that is the source and the destination size should be the same. Okay, the size should always be the same, because if there is a size difference, say for example in the type difference, int means int, you can transfer int operands only. You cannot transfer float into int. Can you do that? The size is larger, it won't fit. So like that, the operands, basic types has to be same. Alright. So you are move. First we will see about move. Move is the instruction where how this instructions execute is from right to left. So we are whatever is available in this will be shifted to this. Okay. So either it can be a register. See, you have register and register. You have memory. So some content from the memory can be shifted to the register, or some content from the register can be shifted to this register. Okay. Or some memory transferred to memory, from some register to some memory. So basically a move instruction is between two similar things, register to register, memory to register, but the fact is the size should be the same. Alright. Next is exchange. Okay. In this, you're transferring you're transferring contents from register 1 to register 2, register 1 to memory. Alright. This is another type of instruction. Next type of instruction in data transfer instruction is push. So you can push some values. Where do you use this push and pop? Where do you use? You basically use it in stack. Okay. Push and pop, you basically use it in stack. Okay. So what you are going to push into a stack or pop from a stack? Some data or some instruction which is available in the stack. So you are going to have it that push some value. So push some memory address. You are going to push some value. You can push operator, you can push operands, you can push some address also. Memory means address, so you can push an address also. Alright. Next is pop. What is inside the stack has to come out. So the last or the topmost will come out. So what is in the stack? Either it can be operator, operand, or memory address. So pop the topmost element. Either it's a memory or operator or a operand. In. Okay. In and out. So you're going to set the values. Whatever value is there, you're going to change it or shift it to A. You're going to move in, move out, like that. Okay. Similarly, out. What is in A, you're going to shift it to data, DX. Next we will see about arithmetic instructions. Basically, we know the operations, arithmetic operations. Add, subtract, multiply, divide. So these are some common operations. So these operations can be done in a 8086 microprocessor. 8086 does some work. What work? Arithmetic works like adding, subtracting, multiplying. Okay, it does some basic works. So for that, add is the instruction. To perform that instruction, what do you require? You require two operands. So you need either that the operands can be register and register, or address and a register. Two addresses, it can be any way. That is what is given here. Registers perform on two registers, operation performed on register and memory, memory and register, so vice versa. You can perform add operation on accumulator and data also. Okay, if there is a L, what does it mean? Accumulator, lower order. Okay, generally AX na any type, any accumulator, lower order or higher order. Okay, understand? So here you are performing addition operation on register and memory, or memory and register, memory or register memory, like that. Okay. Next we will move on to sub. What is sub? Subtract. So same way you can perform on register, you can perform on memory location, or you can give the data directly. Add A plus 10, like that you can give the data also directly, isn't it? Like that. So you are going to perform subtract operation on two registers, register 2 and register 1, register and memory, memory and register. Okay. Next is INC. Add, subtract. This is multiply. This is division. What is INC, DEC? Very good. Increment and decrement. So you want to increment. How do you? I plus plus. What do you do? I equal to I plus 1. Like that you say. It's incremented by 1. Decrement now it's minus 1. So you can either specify a value 1, add 1. Or you can specify that value's address. Where is that 1 stored? It is stored in some memory, isn't it? So you can specify that address, or you can specify that register where that value is stored. 1 is the increment value. Where is this 1? Either you can directly tell 1, or you can tell the address where it is located, or the register where it is located. So 3 types you can tell. So you can specify increment, the value, increment, address is given. So what content is given in that address, that will be incremented, plus 5 or plus 10 in that memory location what is there. Then otherwise that register where it is stored. Same way decrement. Decrement 1 na 1, where is that 1? 1 is a straight value you are giving, decrement 1, or you can tell in that location some value is there, decrement that value, or you go to that place, there some value will be there, you decrement that. It is there in that register. So what value is in that register, that will be decremented. Okay, so 3 types you can tell. Either you can give the value, you can tell the address, or you can tell the register. So yeah, that value will be decremented or incremented. So command is INC or DEC. Multiply, MUL. Okay, so you're going to multiply some value, some content from, and some value. You can multiply some content available in some location. Either it is the address given, or you can specify the register where that operand is available. Okay, where is that register? In that register some value is there. You take that and multiply, like that also you can tell. Okay, so and some memory. You can how much you want to multiply. Multiply 10 times, 20 times, or multiply A into B. The other operand is also you can available in the address, or it is available in the register, or it is a value. Okay. Next is division. You will get, there are 2 things when we do division operation. One is you get a remainder, you get a quotient, then you have a, what is that? You have remainder, you have quotient. So for 16-bit, how is it done? 8-bit is used, and then remainder is stored like this. Mod A, if you do perform this operation on accumulator, A register, If you do this on A register, then mod this is stored in the A register. For 32-bit, how it is multiplied and then it is stored. Next we will move on to CMP. CMP compare. So you want to compare two elements, or you want to compare one memory and another variable value. Okay, so like that, what will be the result of comparison? What will be the result of comparison? You compare two things. What will be the result? Either it will be true or false. So these are some operations, logical operations. What are the basic logical operations? AND, OR, XOR, test and all these things. So we are going to perform AND operation on 2. Again you require 2 operands to perform AND operation. 2 registers or 2 memory, memory to register, register to memory, like that. Okay. Next OR operation. Again you require 2 operands. One is one can be register and another can be memory or memory. Alright. Next is XOR operation. Next is test operation. So you are going to get output. Comparing, again test is again equal to similar to test. Compare. So you are going to compare 2 things. 2 operators or 2 memory or memory and register, like that you can test. You will get a result. Okay. These are some operations. Next is string instructions. You have string operations also on a microprocessor 8086. You can do string operations. What is basically a string? It's a collection of characters. Okay, you can have collection of characters. Here we don't have characters, so we have words or bits, ones and zeros. So that is what our microprocessor understands. It's a low level one. High level now you can say it is characters. Programs like C, C++, there you can say it is characters. Here since it's low level, it understands only bits, so ones and zeros. You want to repeat, you have to prefix it and then execute, perform the operation. Okay, so string instructions which end with S or SP or SW. SP for string byte. S alone represents string instruction, and if the word contains SW, it is string word. You need to calculate the offset. You will be calculating the offset value while performing the string operations. Okay, what is the address needed? For that you require the SI register, string index register, and then you have the destination index register. In that you need to calculate what is the status and then increment the value by 1. If it is 1 byte or 2, you add 2 to it if it is a word. Okay. Now what are the works we do? We want to repeat, REP. You want to repeat a word or that string, bits of information you want to repeat, then you can use REP. That's the thing. In that you have REPZ and REPE. What is what type? Then REPNZNE. Okay, these are types of string operations, repeat operations. Then you have string move, string compare, then scan and compare, load, then store. These are some operations. So in repeat is the code. What is the code? Mnemonic code which we are using. In this we want to repeat the instruction for some times. Okay, in Malayalam how many times AM is repeating? You understand, no? So in that, how many times that particular AM is repeating in Malayalam word, like that you want to specify, you can do that using this REP. Next is moving, move S. We have instruction move for normal operations. So this instruction is for string. So move S. You add the word, you add the character S to it. So instruction is move. If you put the keyword S, then this keyword is move S. They're going to perform this operation on string. So you're going to move some value from one location to another location. This is comparing. So CMP is for compare, S is for string comparison. Next is again scan, find out what is available or not available. So scan, in this you are going to find a particular word is there in that big word or not. Loading the bytes, load S. You are going to store the value. The string value you want to store it or you want to retrieve it. For that, store is the code. Next set of instruction is the process control instructions. These instructions, these are just the codes available. ST, CL, CM. These are some process for the processor. You want to give some instructions. Okay, we saw about memory instructions, register instructions, okay, string instructions. Now we are going to see about process for the process instructions for the processor. What are the process instructions? Okay. Next is control instructions. Call, jump, these are all control instructions. Okay, you want to call from some location, some memory location. You are calling a subroutine or you are calling a function. So you specify call and then the function name or the subroutine name. Then this is call is the keyword. You want to return function value, you are going to return. So in that you are specifying the return and then the value or the name or a variable. So what you are going to return. You want to move or jump immediately. You want to do it, move is slow, jump is immediately you do it. So for that you use JMP. Okay, you want to jump to a register or to a memory location or to some place immediately. Okay, then that is unconditional. We have some branching instructions. Branching instructions, what are the branching? Conditional branching and unconditional branching. Control transfer. Branching instructions are called as control transfer instructions. The control is transferred. Okay, the control is moved from one place to another, or otherwise branch, you can say it as branch. In that, conditional branch and unconditional branch. Okay, for example, jump, if some condition is true. Okay, if this condition is satisfied, then you do this. Alright, jump if the condition is satisfied. Jump if not equal. Jump if the value is great. Jump if is greater and equal. So you have some conditions like this. In this condition, unsigned conditions, you have jump if it is equal, jump if it is not equal. In this, jump is above, jump if this condition it is jump is above and equal. JB if above, JBE, jump above and equal if this value is true. So these are some control transfer instructions. In this, you are going to set some flags. Wherever there is a F, it is flag. So what is CF? PF? What we saw about some flags, no? Control flag, carry flag, parity flag. Okay, so we have to, when these jump, when these controls transfer instructions are executing, we have to set these flag values. Okay, the basic concept is whenever this jump sort of instruction, immediately the control is changing, control is transferring. In that cases, you have to use these flags. Okay. Next we will move on to assembler directives. Assembler directive. In this, what is an assembler? Assembler, instructions to the assembler, when instructions are given to the assembler, needs to be executed. Okay, all instructions are to be executed. When the instructions are given to the assembler, it will give out whatever the codes which we have given. Move, jump, like that we have given some codes. Those codes have to be executed. So what the program which we have written this previously, we have written some programs, no, like this. So all this is given in assembly language. Move, jump, add, all that we saw, that is given in assembly language, mnemonic codes. So when we have to execute that assembly language code, okay, what has to be done? Instructions have to be executed. Whatever is required, the data has to be fetched, the data has to be decoded, the data has to be given, processed. So this is called as pseudo instructions. This is called as this is the execution process of the assembly language. Okay, so any code or any program written in mnemonic code has to be executed. Alright, it is given in assembly language. All the instructions which we gave, the mnemonic instructions which we gave, they are all in assembly language. It has to be executed. Alright. You require some directives. What are the directives? DB is one of the directive. Next is DW. You want to define a word. You are going to give a word or create a word. It's like creating a variable. Okay. So for that you use the word DB. You want to define the word. Then this again DW. You have lots of assembly directives available. Segment end. This is used to show that which the program is there, which is the start and which is the end of the program. Okay, so while you write the program, you're going to write some programs. Okay, like adding, subtraction and all. How you write a program, normal high level language program, same way you're going to write some low level language program, that is assembly program, using these codes. Okay, in that you have to tell which is the starting, which is the ending. So segment start, segment end is specified using this. You are creating variables, you assume something, then you can use the word assume. Next, you are going to use some address. While using some address, you are going to specify, if it is an address now, you are going to specify org, which is the origin. Org is used for origin. Okay, next is you can specify end for terminating the program. All programs end with the END keyword. Next you have even. It is used to store the address, which is the even address. Next you are going to use this keyword EQ to attach a value to the particular variable. Any value you want to attach, then you can use the EQ. Next we have a keyword, this assembler directives keyword, which is PROC, which is tells procedure or that program is starting. So the first keyword should be PROC. The program is starting. The first one will be PROC. Next is end, end of the procedure. A call, a function, you know function calling and all, no? In that some call is there. Then you can use FAR, inter-segment call. Then intra-segment call, NEAR is used. Alright. Then general form. You are using the word or the directive word called as short. So this you want to use it along with some statements like jump some value you gave, or jump to fourth statement, sixth statement, like that if you give. For that you can use jump, short. You are writing some macros. What is a macro is similar to a function. Okay, you want to do some work repetitively, then you can write it inside a macro. So to begin a macro, you have to use the keyword macro, and end the keyword use macro using the NDM keyword. Okay, so I think I'll close the session with this. Just go through these things. See, this is the overview of what you are going to learn in full. Okay. So you're going to see all these things. Next is memory interfacing. You're going to study about how to process memory, processor memory, main memory, secondary memory. Just listen here. Excuse me. The memory organization of 8086. All this is there in our syllabus, so I have covered almost 3 units now. So you have the RAM, you have the ROM, all that. So just go through this, please. Don't while your time. Just see whatever is available. You have to write coding, you have to write programs. So this is just an overview of what you're going to learn this entire semester. All right. Thank you. So interfacing the memory. So this is, I think it comes under 4th or 5th unit, memory interface. Okay. So how you're going to interface your monitor, how you're going to interface your I/O devices. You're going to connect your LCD screen or the keyboard. I'll show you one microprocessor kit, how it looks. One small microprocessor kit. It won't be like this. Okay, it's a small kit. I'll show you that. Then you want to do some interrupt programming and all. So this is the 5th unit. Alright.